we'll work a couple of examples here today and wrap things up. All right. Very good. You guys at home should see what I've got on my screen. And dismiss. There we go. All right. So obviously this equation has a fraction in it. Hey, Coach Smith.
It's a good life lesson.
What's that? Oh, waiting until the next morning? You're daggone right it is. He and I were discussing last night how it's smart to respond to emails after you've slept on it. If you're getting fired up or you're getting frustrated or whatever, always wait till the next morning before you send, and it oftentimes works itself out, as it did in our case. So he and I were just discussing that this morning. A good life lesson. There was one time I got heated with a professor of mine over at CBU. And she had, I don't know what she was doing. She was in charge of the program that I was working in when I was in grad school. And and I guess there's no other way to say it. She wouldn't give me what I wanted as far as like letting me take a particular class in a particular order. And so I wrote her this snippy email and sent it. And then the next day she came down on me like a ton of bricks. And she was totally right. She was like, you should not have sent such a snippy email. And she's like, I would have been willing to help you if you had not been such a jerk about it. And so I was like, dude, you're right. I'm sorry. And all's well that ends well. It worked out fine, but lesson learned. Faux show. Tiago, make sure you cover your nose up, please. All right. Anyway, I digress. The equation that we've got in front of us here is one that has fractions in it. And we talked yesterday about fractions and how to get rid of the fractions. So what should I multiply on both sides here to kill off those fractions? What do you guys think? Can you spot an LCD using inspection? Go ahead. Yeah, 4. 4 is my LCD here. So if I multiply both sides by 4, then it will kill both of those fractions off for us. Now here's the problem. Oftentimes students will say, I want to multiply the fractions by 4, and they think that gets the job done, but it's not the case, because the rule that we're using, our multiplicative property of equality, says that you have to multiply the entire left side and the entire right side by that factor. So if I multiply by 4 on the left, I also am going to have to do it to not just the fraction, but also the 6. Okay, note that right there. That if we want to take 4, which is our LCD, and we want to multiply it, then we should certainly multiply it times everything on the left and by everything on the right. Okay, 4 over 2 gives me 2 left over and a 4q plus 3. Again, because 2 goes into 4 twice. And then as we're multiplying by 6, 4 times 6 is 24. Over here it cancels out in its entirety, and we got 3q plus 5. And now we've got an equation that has no more fractions in it. No more fractions, as Elmer Fudd would say. No more bullets. No more bullets. Duck season, wabbit season, duck season, wabbit season. Wabbit season, duck season, fire! You know what I'm talking about? Oh, it's a classic, Quentin. It's a classic. We talked about Looney Tunes in here yesterday, didn't we? All right, that's a classic. That's not the same one as Barbara of Seville that we mentioned yesterday, but that one's great, where Bugs uses a little reverse psychology and gets Daffy to like about 4 times in a row admit that it's duck season and that Elmer should shoot him. But I digress. Can you guys go ahead and take this one and solve it out for me? Now that we have eliminated the fractions by using the LCD, we are free to solve. You should be combining like terms, using that distributive property, combining like terms. And then it'll be a dog-cat scenario. You can get the dogs on one side, the cats on the other. I announced for our freshman football game again last night. My voice is pretty much shot for the week. So I'm going to suck on this cough drop for a little bit. All right, John Zweig, what do I do? What's my first line going to look like after we kind of shuffle some things out? What do you think, Mr. Tacos? Mr. JMZ, John Boy Taco Man. Can you hear me? Speak up nice and loud.
Yes, sir.
Perfect. All right, what should I do? What's my next step in this process?
Distribute the 2 to the Q and 3.
All right, that's easy enough. Okay, Alex, next. All right. Now we got dog, cat, like we've said before. So I want to move, quote unquote, move my variables to the same side and then move my constants to the other side. Okay, James, what would you want to do to both sides? How do you want to roll? All right, so can you identify, like, we got a Q term here and a Q term there, right? So we want to get those two guys together. When I say dog, cat, it's as though that equal sign is a fence right there, and we've got a dog. Oops. And we got a cat. We got a dog. And we got a cat. And traditionally, dogs and cats don't get along with each other, so we're going to pretend like we want both dogs on the same side of the fence. Team dog. All right. So do we want to move the 8Q over to the right, or do we want to move the 3Q over to the left? And I'll give you the choice. You can choose whichever way. Not at all, my man. Not at all. All right. So he chose, let's move 3Q. Whoops, I deleted that Q there. Let's move 3Q to the left. Now, I like that. That's smart, because I'm going to use an inverse operation that Ben Roos is going to tell me about. What op should we do? He wants to move 3Q to the left. What do I do, therefore? Nice and loud. It's a plus 3Q. What undoes plus? Very good. We want to subtract 3Q from both sides. And remember, fellas, whatever I do on the right, I also have to do on the left. Minus 3Q. All right, so very good, James. We got 5Q plus 30. You had selected to move the Q's to the left. Okay, so Reed, what does that leave me with now? What do I need to do with the other part of this example?
Move the 30 to the right.
Very good, sir. Very good indeed. We're going to move 30 over to the right. So 5Q stays on the left. And by the way, Charlie, what he wants me to, Reed wants me to move the 30 over, quote unquote. And that's sometimes not a really smart way of looking at it. I know physically it's like we're moving it over there, but what are we mathematically doing, Charlie, to get that accomplished? Which would be, in this case, subtraction. So 5 minus 30 is negative 25. And then my last step, last but not least, Mossy, we would do what? What's being done to Q right now? Well, I mean, there's an operation that's being done to Q. 5 what Q? Times Q. Good. And what undoes a times? A division. So I would want to divide both sides by 5. Negative 25 divided by 5 winds up giving me negative 5. All right. So as we practice examples like this, okay, we need to not only get familiar with the notion of, like inverse operations and how we would isolate variables, okay, but we also want to keep things balanced. Remember, whatever I do on the left, I have to do on the right. And we talk about how a plus and a minus undo each other. Moss just said times and divide, they undo each other. And again, what are we doing? We're peeling back the layers. So like if you focused, look where I'm highlighting down here. If you focused on that and you thought about it like an onion, what's the outer layer that we want to peel off first? Well, that's that 30. I can't attack the Q term until I get the non-Q term, that cat, so to speak, until I get that cat over to the other side. Okay. Now, in some instances, we could divide everything by the coefficient. So like in this case, we could have said divide by 5, divide by 5, divide by 5. And that would be fine, especially considering that both 30 and 5 are both divisible by 5. However, that presents an issue if the numbers don't match up nicely. So like, for example, if this was 3x plus 1 equals 7, I most definitely do not want to divide everything by 3 right now. Good, googly moogly. If I divide everything by 3 right now, that would make 1 into 1/3 and 7 into 7/3. And I'm now making things more complicated. However, if I subtracted 1 from both sides, now I can divide by 3, and I can get my answer much quicker that way. Okay, so that little orange example is an example where I would not want to divide everything by 3, although over here in yellow, we certainly could do that. Okay, questions y'all might have? Go for it, Tiago.
How did you get 5
5q equals -25 right here. All right, we subtracted 30 from the left, and so therefore subtracted 30 from the right. So when we subtracted that 30, I forget who had said it, might have been Ben at that point. When we said let's subtract 30 from the left-hand side, then we have to do the same thing on the right, and then 5 minus 30 again is -25, and then we're off to the races dividing by 5. Good question. Other questions? Go for it, Lewis.
Like at the very start when you were distributing to the fractions, like, so are you just allowed to like cross out the 2 because it was a multiple of 4?
Short answer is yes. Okay, so like, and then let me go in and explain. Here's kind of what was going on in the background. We had 4q plus 3 divided by 2. We had 6. Actually, I won't write that in. Good old 6. And then we had 3q plus 5 over 4. And we said, all right, the LCD, the least common denominator, what would help me kill all the fractions all at once is 4. And there are 3 terms here that I must multiply by 4. Everything on the left, every term on the left and every term on the right has to get multiplied by 4. So when we do that, here's what it looks like, sort of the long, drawn-out approach that I did not write down. Okay, is that we are multiplying 4 times that, 4 times that, and 4 times that. Okay, now when we multiply 4 on the top of that fraction, we can now simplify. We don't have to distribute 4 times 4q and 4 times 3 because we can simplify it out. 4 goes into, or excuse me, 2 goes into itself once, 2 goes into 4 twice. So now I've got what I had earlier, which is 2, and the quantity 4q plus 3. Okay, so 2, and then 4q plus 3. Here we got 24. And then over here, look at what cancels out. The 4 cancels out in its entirety. So we did not have to do any kind of distribution there. Lewis, does that make sense?
Yes, sir.
All right, very good, awesome. Anybody else with questions? Quentin?
So the 2 at the bottom of 3, did that just get moved bottom?
It did not get moved from the bottom to the left. It got canceled out, okay? So imagine, make a little sidebar example here. Imagine I've got 7x plus 1 over 3. And then we'll just make like plus 1 equals x minus 5 over 2. Okay, something like that, right? So a little sidebar example. Can y'all write that? We're not going to work this example in its entirety, but I'm going to illustrate to answer Quentin's question about where that 2 came from. I'm going to illustrate. So like, Paul, what's my LCD here? Just using your eyes and inspecting it. What's my LCD? Yeah, between 2 and 3, the least common denominator is 6. Okay, so I would multiply everything by 6, right? So I'm going to come in, I'm going to say 6 times this, and 6 times this, and 6 times this, right? And then we go to canceling. Because 7 over 3, the original fraction right there at the beginning, doesn't cancel down. However, 6 over 3 does. There's a common factor of 3. And so when we cancel out that 3, we're left with 2. Okay, it is as though I split this 6 up as 2 times 3, and I said, ooh, there's a 3. Let's kill off that 3. Nothing's left down at the bottom, so all we have is that 2 times, whatever. Does that make sense? What would be left over? Alex, are you on the call? Alex went. No, I don't see him. Kozlowski, Colin, what would be left over on that third fraction, on the one on the far right-hand side, once we do our canceling?
It would be 2 times 3 and
Cancel something. What would now cancel? Because we put a 6 up top. I just expressed 6 as 2 times 3. So what do you notice? It's up at the top. It's also at the bottom now.
the 5.
You see a 5 on the bottom?
Wait, no, not the 5, the 2.
Yeah, there's a commonality of 2 on the top and on the bottom. So I would cancel that 2 out, and then we would be left with those guys over there, much like we were left with, you know, these guys from the first fraction. Okay, so we'd have like 14 quantity x plus 1. We'd have 6, and we'd have 3 times quantity x minus 5. The fractions now have gone away, and that's our whole goal. The LCD is the fraction killer, right? And then, of course, you could, if you wanted to, you could solve that one out. I'll leave that for you guys to do. I want to talk about decimals now. Decimals, okay? Y'all write this next example down. That's our last example. Decimals are fractions in disguise, okay? Decimals are fractions in disguise. We just got through talking about how to kill fractions. Drew Benton, what was our tool that we used to kill the fractions? The LC freaking D, okay? The LCD. Now, with fractions, that's, you know, obviously where you look at the denominators and you go through the process by which you select the number that has every denominator as its factor, and hopefully the smallest number. That's why we call it the LCD, least common denominator. With decimals, this is what's neat, is that they all have something in common already as far as denominators are concerned. Okay, a decimal is always going to have a denominator of a power of 10, right? So like 0.25, yeah, I know that's 1/4, but 0.25 in its fraction form would be 25 over 100. 0.05 would be 5 over 100. And 2.85 will be 285 over 100. Okay. Now, like I said, decimals are fractions in disguise. Now we can kill off all 3 of those fractions by multiplying by the LCD. And what's the LCD in this case? Call it out with great resound. 100. Okay. Now, the notion of that, you don't have to do that step. You could skip on down and say, oh, look, the largest number of decimal places that I see is 2. Therefore, I need to multiply everything by 10 to the 2, 10 to the second, aka 100. And what's that going to leave me? Well, if I multiply the first term by 100, I got 25x. If I multiply the second term by 100, I got 5 parentheses x plus 3. And if I multiply the third term by 100 to keep things balanced, right, everything on the left, everything on the right, I got 285. And that's the same thing I would have gotten if I had said, let's put 100 on the top of every fraction. Okay? And then you would just say, oh, well, look, that's nice. The 100 cancels out, and we're left with 25x. The 100 cancels out, we're left with 5 times quantity x plus 3. The 100 cancels out, and we're left with 285. Skip over that step and just scoot your decimal places over. Okay? Then I should be able to rely on everybody to go ahead and solve this one out on their own. Okay, right? Let's see, Grove, you want to do the distribution for me, buddy? Ooh, Grove, I called on him and his mic's messed up. Let's get Lewis to do that distribution.
It would equal out to 5x plus 15.
All right, very good. So we got 25x, didn't do anything new there. Then we got 5x plus 15. And there she goes. Now we got a couple like terms. Got a couple like terms. Joe Edwards, you're going to put those like terms together for me, right? What do we got? All right, let's do that first one first. What do you get? So we got 30x. And then he's talking about that 15 and that 285. Okay, Drew Benton, what do I do to get that 15 to be with his buddy 285? Subtract 15 from both sides, and I get 270. Divide both sides by what next? Divide by 30. Mossy, you got that? What do we get? What do you guys get? 9. 9. So you could, in essence, cancel off the zeros, and then 27 divided by 3 is 9. Okay? All right, so this is an example of solving an equation that had decimals in it, and you can either turn the decimals all into fractions. That's one way of looking at it. Or you could just scooch the decimals over. All of them have to scoot the same number of places. So little sidebar example, like if I were going to pretend, I'll just make something up simple like 0.3x plus 0.13x plus 2 equals 0.7x minus 1, right? What am I going to multiply both sides by? What's the largest? Well, okay, so if I did 10, I was going to say, what's the largest number of decimal places? Because 10 would scoot it to where this would be 3x. This will be 1.3x plus 2. And this will be 7x minus 1. Did I kill all the decimals all at once? No, I didn't. Although I killed 2 of them, I need one more power of 10. So in this case, it would need to be 30x, 13x plus 2, and 70x minus 1. We could have skipped over that middle step just by saying, hey, let's times everything by 100. Since I need to move my decimal place to the right twice as the largest number of times to move. Okay? Questions at all? You'll feel pretty solid? All right. Here's a little practice quiz for you. You've got 8 minutes to do these 3 problems. I say it's a practice quiz because I'm not going to grade it. You're going to grade yourself. You're going to give yourself a grade. This is kind of a check for you. Say, "Ooh, yeah, I'm doing well." Ooh. Or you're going to finish this quiz and you're going to think, "Oh, Nikes, I need to work some more on this. It's tough." So sit quietly, work this out. You guys that are at home, you can see this. Just do it in your notes, do it on pencil paper, and let's see what shakes out, you guys. Tell you what, while you guys are working, I'm going to use the restroom real quick. BRB. How we doing, fellas? Y'all finished with a couple of them? Maybe working on that last one still? Okay. Give me about 1 more minute and we'll wrap this up. I'll show you the answers. We won't have time to go through all of them, but at least you'll be able to check and see how you did. All right. Even if you're not finished, I'm going to project the answers here. See how you guys did. The bonus, by the way, is one of my faves. It's called Interstellar. Not sure if you've seen that before. Here was our answer for the first one down there at the bottom, -2. We multiplied by our LCD of 8 to kill off those fractions. So -2 gets the job done. The middle number, the middle problem there, again, you're just using the distributive property. I would caution you, and this is one of the things we mentioned this week, that when you're subtracting a group, right? If I'm like, "Dadgummit, Mossy, I'm sick of your row, just get out." I don't just take the first guy out. Okay, so like if we're subtracting p plus 7, we got to subtract p and subtract 7. So that's why both of those are negative. Bless you. So we get -4 as our result. And then last but not least, this one was a trick question. It was one of those special cases that we talked about yesterday, right? What do we call that when you get something like -51 equals 105? Starts with C, ends with contradiction. All right, is a contradiction. Bless you again. So there's no solution. Okay. And that's legit as far as the possibilities are concerned. There are other ways of working this, and I showed an alternate way to the class last year when we went through that, but I would just approach it the way that we did there. Our time is up, fellas, and I hope you all have a wonderful weekend. Live peaceably with good cheer in your hearts, for it is Friday, and live Jesus in our hearts. Hope to see you guys again on Monday. Thank you so much.